Hello! In the last lecture, you learned that linear equations can be represented as lines. Now we are going to consider this equation in order to see more details. Here we have the original equation, 4 times x minus 1 divided by 2 multiplied by y is equal to 1. This is an example where we can represent y as a function of x. But we could also have done the reverse. We do this by isolating y in the equation, as shown here. So, we are sending for x to the other side of the equation. It was positive and now it is negative. Now we have the original part of the equation here. It is equal to minus 4x plus 1. We are just sending 4x to the other side of the equation. At the end, y is expressed as a function of x. In the case you don't understand all this simplification, you can ask for an LLM. In this example, we are using DeepSeek, and we have the following prompt. This is the original equation. This is the result. Explain step by step. So we are going to solve the original equation to find y in terms of x. First, we have the original equation. The goal is to solve for y to express it as a function of x. The first step is to isolate the term containing y. Here we have the first result. We are sending for x to the other side of the equation. So here we have 1 minus 4x. We could also have minus 4x plus 1, as shown in the slide. Step number 2, eliminate the negative sign. So we multiply both sides by minus 1 to make the coefficient of y positive. So we can visualize here 1 divided by 2y. It was negative, now it is positive. And regarding the other side of the equation, before we have minus 4x, and now we have 4x. Before we had positive 1, and now we have negative 1. Step number 3, solve for y. So we multiply both sides by 2 to eliminate the fraction. 1 divided by 2 is equal to 0.5. 0.5 multiplied by 2 is equal to 1. For this reason, we only have y here. Then we need to multiply 4x minus 1 by 2. 2 multiplied by 4 is equal to 8, and 2 multiplied by 1 is equal to 2. So this is the final result, according to the slide. This can also be written as fx is equal to 8x minus 2. And here there is one additional step if you want to verify if the transformation is correct. You just need to replace y by 8x minus 2, which is the final result. See here that 1 is equal to 1, so our solution is correct. Since this is a linear equation, this form represents the equation of a line. as we can visualize here, x and y can have any real value, but because they are related through the equation, selecting a value of x determines what the value of y is, and vice versa. This line represents this relationship between x and y. For example, when x is 0, y is minus 2. In this point, when x is 0.5, y is 2. When x is equal to 1, then y is equal to 6. When x is equal to 2, y is equal to 14. And finally, when x is equal to 3, y is equal to 22. In this example, as we have two variables, x and y, the line is represented in a two-dimensional space, but we can also have lines in spaces with more dimensions, such as equations with three variables, for example, x, y, and z, which would be represented by a three-dimensional line. Because visualization with three dimensions are more difficult to visualize, the course will focus on two-dimensional problems. But once intuition in two dimensions is understood, the same reasoning applies to n-dimensional problems. Linear equations are usually represented with one variable being a function of another, where y is the dependent variable because it depends on x. So it is isolated, meaning it has no coefficient. Just a reminder that coefficient is the number before the variable. X is the independent variable because it is the one that determines the value of y. The equation has two coefficients. The angular coefficient, which is called slope, and the linear coefficient, which is called intercept. But what do these coefficients mean in practice? Let's visualize one example. Y is equal to 8 multiplied by x minus 2. See that now we have the coefficients, the angular coefficient as well as the linear coefficient. Now we can visualize this graph. The linear coefficient is where the line cuts the y-axis, which corresponds to x equals to 0. On the other hand, the angular coefficient represents the slope of the line. Mathematically, it is the tangent of the angle of inclination of the line. That is the change that occurs in y with respect to the change of x. In this example, for every increment of 1 in x, y increments 8. For example, when x is 0, y is minus 2. On the other hand, when x is 1, y is 6. So we can confirm that for every increment of 1 in x, y increments 8. since there are 8 positions between -1 and 6. Let's see another example. When x is equal to 2, y is equal to 14. So 14 minus 6 is equal to 8. There are 8 positions between the numbers. So now it is easier to understand the angular coefficient. In this example, the value is equal to 8. So we have this increment of 8 positions every time x is incremented by 1. For this reason, it is called the slope of the line. If the linear coefficient was -5, the starting point of the line would be in this position I am pointing the mouse, in -5 in y-axis. Now let's see how to represent linear equations with more than one independent variable. Here we have one example. Y is equal to a1 multiplied by x1 plus a2 multiplied by x2 and so on. At the end, we have the linear coefficient. Each variable has its angular coefficient, which indicates how much y varies for each variation of that variable. And the equation has a unique linear coefficient, which can be represented as the sum of the linear coefficients for each variable. It indicates the value of y when all variables are equal to 0. Now we can visualize the coefficients a1 to an, as well as the angular coefficients of each variable. And we have the linear coefficient of the line. Now let's see a numerical example, so it will be easier to understand. We are going to consider the expenses of a restaurant. For example, y is equal to 7.5 times x1 plus 8.25 multiplied by x2 and so on. We can consider that y is the total expenses. Regarding A1, can be considered the beverage price and X1, the beverage quantity. A2, the starter price, X2, the starter quantity. A3, the main price, X3, the main quantity. A4, the dessert price, and x4, the dessert quantity. And finally, B is the artistic cover. So we can conclude that the total expenses is a function of the consumption of individual items, represented by the variables x1, x2, and so on. The price per item, the angular coefficients, represents the increase in total expenses for each unit of item consumed. At the end, we have an independent rate of consumption. This is the linear coefficient. So, for example, if a person asks 2 drinks, x1 would be 2. If the person asks 3 starters, then x2 would be equal to 3 and so on. That's all for this lecture, that you have learned a basic understanding of the linear equation. See you next time!